if you're looking to really get into the weeds on something interesting, today we're going to be covering salt-induced precipitation.
Or as it's more commonly known, salting out.
Right, salting out.
Yeah.
And this is a technique that's used in biotech a lot for separating stuff out, like proteins from a mix.
Yeah, it's really useful for like cell mass removal and purifying proteins.
Okay, cool.
Yeah.
And we've got some sources here that talk about how it works, how to do it.
The applications.
Yeah, applications, advantages, and disadvantages, limitations.
Yeah.
The whole 9 yards. So our mission today basically is to figure out just, the key things about salting out and why it's useful.
Perfect.
So maybe we can just start off with the basics of how does this even work?
Right. So the basic principle behind salting out is that proteins have different solubilities in water depending on the salt concentration.
Okay.
So if you imagine you have a protein in water, the protein likes to be surrounded by water molecules.
Right.
But when you add a lot of salt to the solution, the salt ions, they also want to interact with the water. Okay.
So now there's this competition between the salt ions and the protein for the water molecules.
Oh, so it's like a crowded room kind of thing.
Exactly, like everyone's trying to get to the snack table.
Right.
And as you increase the salt concentration, there are fewer and fewer water molecules available to interact with the protein.
Okay.
So the proteins are kind of forced to interact more with each other.
Right.
And because they're hydrophobic, they don't really like water.
They want to stick together.
They want to stick together, and they start to clump up and eventually precipitate out of the solution.
Oh, I see.
Yeah.
So it's almost like the salt is hogging all the water.
Exactly.
And then the proteins are like, well, fine, we'll just hang out with each other then.
Yeah, exactly.
Okay, cool. So how do you actually do this, like in a lab setting?
Right. So the technique itself is pretty straightforward. You take your sample, say you have a solution of leucine cells, which is basically broken open cells.
Right.
And you start adding a very concentrated salt solution, commonly something like ammonium sulfate.
And you add it until you reach a final concentration that's usually somewhere between like 20 and 80%.
20 to 80% ammonium sulfate.
Ammonium sulfate, exactly.
Okay. And so you just dump it all in at once?
No. So you got to be careful. You need to mix it really well.
Okay.
So the salt is evenly distributed.
Right.
And then you let it sit for a while for the precipitation to happen.
Oh, okay.
Sometimes you can just let the clumps settle on their own.
Right.
But more often you'll use a centrifuge to spin everything down.
Oh, yeah.
And then you can collect the solid precipitate at the bottom.
Okay, cool. One of the sources mentioned something called fractional precipitation.
Right.
What is that?
So different proteins have different solubility levels.
Wow.
So if you gradually increase the salt concentration in steps.
In stages.
Yeah, you can actually selectively precipitate out different groups of proteins.
Oh, that's cool.
Yeah, so it's a way to do like a partial purification.
Oh, okay.
Separate out some of the proteins from others.
So it's not just like everything comes crashing out all at once.
Exactly.
So you can actually fine-tune it a little bit.
Right, and the order in which they precipitate can actually tell you a bit about the protein's properties, like how hydrophobic it is.
Oh, that's interesting.
Yeah.
So where do you see this being used in real life?
So salting out is really great for the early stages of working with biomolecules.
Okay.
So if you have a huge volume of liquid and you need to concentrate the proteins,
Right.
salting out is perfect for that.
Okay.
It's also really good for removing the bulk of the cell debris after you've lysolized the cells.
Right.
And in fact, ammonium sulfate precipitation is a very common first step in protein purification procedures.
Okay, so what are some of the advantages of using this method?
Well, first of all, it works for a wide variety of biomolecules, not just proteins.
Oh, cool.
So it's very versatile.
Okay.
It's also pretty cheap, which is always good.
Right.
And this is interesting. Ammonium sulfate can actually stabilize some proteins, which helps to keep them active during the purification process.
So it's not just yanking them out of solution, it's actually helping to preserve them.
Exactly, yeah.
That's a nice bonus.
Yeah.
But, obviously there must be some downsides to it, right?
Right, of course. No technique is perfect.
Yeah.
So the biggest limitation is that it's not very selective.
Oh, okay.
So you're precipitating out a whole bunch of stuff, not just your target protein.
Not like a magic bullet.
It's not a magic bullet, yeah.
Yeah.
You'll need to do more purification steps afterwards.
Right.
Another thing is that working with concentrated salt solutions can be a pain.
How so?
Well, it can be corrosive to your equipment,
Right.
and you definitely need to remove the salt later on, which is a whole nother process called desalting.
Yeah. Okay. And is there anything else?
Yeah, one more thing. While it can stabilize some proteins, high salt concentrations can actually denature others.
Oh, really?
Yeah, so it's kind of a double-edged sword.
So it can actually make them lose their structure and stop working.
Exactly.
Yeah. Okay, so it sounds like salting out is a good first step for getting rid of some of the junk and concentrating your proteins.
Yeah, it's great for that initial bulk separation.
But you'll need to do more specific things later on to actually purify the protein you want.
Exactly. It's not the end-all be-all, but it's a really valuable tool to have in your arsenal.
Okay, cool. Well, that was a really interesting deep dive into salting out.
Hmm.
I learned a lot.
Glad to hear it.
It makes me wonder if scientists could design like even more specific types of salting out procedures,
Yeah, that's a great question.
like maybe using different kinds of salts or controlling the rate at which you add the salt.
I mean, there's definitely room for optimization.
Yeah,
It'd be interesting to see what researchers come up with.
yeah, it'd be really cool to see how this technique evolves in the future.
Absolutely.
Okay, well, I think that's about all the time we have for today. So thanks for listening to the deep dive, and we'll see you next time.